Hello all, welcome to Tech Horizon Hub. In this detailed tutorial, we will understand how to use hosted control planes on IBM Storage Fusion HCI system with Fusion Data Foundation. Hosted control plane and Fusion Data Foundation is supported only from OpenShift 4.14 release. By default, IBM Storage Fusion HCI system is shipped with OpenShift 4.12 release. Let us first upgrade our IBM Storage Fusion HCI system OpenShift version to 4.14 release. We are logging into IBM Storage Fusion HCI system to do initial validation, checking OpenShift version, checking health of the nodes, see if any storage is already configured and storage classes exist, and if the IBM Storage Fusion operator is installed and healthy. We will follow official IBM Storage Fusion documentation to upgrade the OpenShift version. We will first acknowledge the API removals in 4.13 version before starting the OCP upgrade. Then we will set the upgrade channel to 4.13 stable. Now we upgrade the OpenShift version from to 4.13. Upgrade would take some time. Keep monitoring the progress. Once the upgrade is complete, validate if everything looks fine and healthy. We will proceed ahead with another upgrade of OpenShift from 4.13 version to 4.14 version. Acknowledge API removals in 4.14 OpenShift version. At the time of recording this, the 4.14 OpenShift release stable channel was not available, so we use 4.14 fast channel. Let us proceed to upgrade to OpenShift 4.14 version. Monitor during upgrade. Once the upgrade is successful, verify the health and status of the cluster. Now we go ahead to install and configure Fusion Data Foundation storage type on Hub cluster. Log in to the IBM Storage Fusion user interface. Select Services menu. You would see both Data Foundation and Global Data Platform tiles. Select Data Foundation tile. It expects to have minimum 6 storage nodes in the cluster. Let us go ahead and add another 3 discovered nodes. It would take some time for the nodes to be added and ready. Wait for the nodes to be part of cluster and healthy. Now we will go ahead and install Data Foundation from Services tile. While the Data Foundation is being installed, you can monitor the operators being installed and storage classes being created in background. It would first install LVM storage operator and create LVM HCP ATCD storage class. Wait for the install to complete and healthy. Now that the install is complete, let us go ahead and configure storage. While the storage is being configured, monitor for the new storage classes being created. This would take some time. Once the configuration is complete, check for the health. Now we have all the storage classes created and Data Foundation installed, configured, and healthy. We will now install all the prerequisites required for the hosted control plane. OpenShift virtualization, Metal LB, and advanced cluster management operators. Start with installing OpenShift virtualization operator. We will install it from the operator hub. Once operator install is complete, create hyperconverged instance. For this demo we are using all default values. Once the instance is created, you would see a new virtualization menu. We would check the menu and we have no virtual machines created yet. In the next step we will install Metal LB operator from the operator catalog. We will now create Metal LB instance with all default values. We will create IP address pool. For this demo our cluster is on private network, so we would use IP addresses in the same range, which I am sure no one using it. You should bring your own IP address in this step. In next step create L2 advertisement instance. It refers to the IP address pool we created. Now we have all required Metal LB instances created. In the next step we will patch the ingress. Let us install Advanced Cluster Management from the operator catalog. Once Advanced Cluster Management operator is installed, create Multi-Cluster Hub instance. We are creating Multi-Cluster Hub instance with default values. Once this Multi-Cluster Hub instance is created and running, you would see a drop-down on top left to switch between all clusters and local cluster. We have installed all the prerequisites needed for the hosted control planes. Let us verify all of them once. Advanced Cluster Management will also install Multi-Cluster Engine for Kubernetes operator. Let us have a hands-on with hosted control plane now that we have our IBM Storage Fusion system ready with all the required prerequisites. Switch to all clusters from drop-down. To view the Advanced Cluster Management interface and click on Create Cluster. From the various available infrastructure providers, select Red Hat OpenShift Virtualization. While this video is being recorded, hosted cluster is CLI based only. So as a first step before created hosted cluster, let us download HCP CLI. I have it already pre-downloaded it. Check the help of HCP CLI. Check the official documentation for example reference. To create hosted cluster, make sure to use this etcd storage class for the hosted cluster etcd storage class. Based on the reference example for creating hosted cluster, we exported certain variables. Here for release image, we are using latest available during this demo recording. Now let us use HCP CLI to created hosted cluster. As discussed before, we are using etcd storage class for etcd. Here we are using RBD storage class for virtual machines. Make sure to define volume mode and access mode if the storage profile is not set. After verifying all the values, let us go ahead and create hosted cluster. Watch the events in the cluster namespace to check the progress of the hosted cluster creation. Check in the multi-cluster user interface for the hosted cluster creation progress. To check the progress further, you can look in the pods being created, or the persistent volume claims, or the virtual machines in the hosted cluster namespace. Once all the pods are up and running, persistent volume claims are created and the virtual machines are started, then the hosted cluster will become healthy and ready shortly. Let us access the hosted cluster we created now. Once you log in to the hosted cluster, do the initial checks. We see here the infrastructure provider as 𝐎𝐩𝐿. Check for the storage classes. Check for the health of the nodes. See if any operators are installed on hosted cluster. Now inside the hosted cluster, we will automatically install Fusion SDS, Fusion Data Foundation Client, and run a stateful application to test. To install Fusion SDS inside hosted cluster, we have to add Fusion base label. We can do that directly from the multi-cluster user interface, as we see now. Click on label and add Fusion base label. This will automatically install Fusion operator on the hosted cluster. Wait for the Fusion operator to be installed and ready on hosted cluster. Now log into the Fusion user interface on hosted cluster. We see no services installed on hosted cluster. Following the documentation, we will not try to install Fusion Data Foundation Client on the hosted cluster. To install Fusion Data Foundation Client, we add Fusion FDF label. The Fusion Data Foundation installation gets started on the hosted cluster. See the operator is succeeded. Wait for the Data Foundation to be healthy on hosted cluster. Also check for more details in Data Foundation menu. We can check for the storage class is created. Now our hosted cluster is ready to run stateful applications using Fusion Data Foundation storage. We are now creating a persistent volume claim using CEPHFS storage class. Creating 1 GB PVC. Wait for the PVC creation to be successful and bound. We will now deploy BusyBox application using the PVC we just created. Wait for the pod to be in running status. We will now enter pod terminal and see the file successfully created. This ends the example of running stateful application on the hosted cluster consuming Fusion Data Foundation storage class. We will now clean up the hosted cluster we created. We can select a hosted cluster from the Advanced Cluster Management user interface and select the Destroy option. It asks to enter cluster name to reconfirm. In this demo, we will destroy the cluster using HCP/CLI. This concludes end-to-end detailed tutorial of hosted control planes on IBM Fusion HCI system using Fusion Data Foundation. Thank you for watching. Please consider subscribing for more content like this.